Welcome to 4.1. In this lesson, we're going to look at growth and decay and exponential functions. So we're going to be working with certificates of deposits. And certificates of deposits is the type of investment people use because it's safe and predictable. So we're only going to look at fixed interest rates, and we're going to know some keywords like term and principal. So remember, this is compound interest, not simple interest like we've done before. Annually happens once a year. Some other key terms or compounding periods are quarterly, monthly, and daily. So here's a 5-year CD. You invest $1,000 principal, right? So that's the P, and the term is 5 years at an APR of 2%. So the compounding year is 1 year. So how much will you have in your first year? So you're going to plug it into this formula, and that'll be 1,000 plus 1,000 times 0.02. All right, because we have to move that decimal twice. And you're going to use that answer, so use the answer from above, and do the same thing. So you're going to repeat these steps over and over. So in the answer above, we got 1020. So then for 2 years, I'm going to use year 1, but multiply it similar to what we did for the 1,000. And whatever I get for this answer, I'm going to keep repeating. So I get 10,040 and 40 cents. So for year 3, that's what I'm going to use to start my calculation. So you can see this repeating. Now there are actually different ways to do this, so that's what the next steps are going to take you through. If I have 2 of the same number, I can rewrite that using exponents. So the 1,000 will be there, but then this 1.02 I would raise to the second power because there are 2 of them. So we can use that approach and say, after 2 years, all right, here is our answer. And so you can keep doing that for more and more replacements. For 3 years, it would be a 3 up there. 4 years, it would be a 4. So the pattern, here we saw this P plus PR. Well, now we started to see this P times 1 plus R raised to the T. So that is going to be my new formula for compounding interest. So use that formula for these other bigger numbers, right? Because it would be a lot of repeating if we had to use it for those. So A equals P 1 plus 0.02 raised to the 10th power. And for that P, we'll actually plug in 1,000. So when I plug it in the calculator, I get 1,218 and 99 cents. Now from the previous question, you're going to plot these. So you're going to estimate them, right? We would start at 1,000, then you should see a curve. Right? This is called exponential. Remember, linear is a line, exponential is going to start at one point and go up. That would be growth. Whereas if it was decay, right, it would be going down. So we came up with a formula, and we just want to keep reinforcing that formula. So P1 plus R to the T. And we're going to expand that in a few seconds. So let's say if we had monthly instead of yearly, right? So I would have to divide by 12. So look at lesson 1.9 if you don't remember. But we're going to take that 2.4, make it a decimal, and divide that by 12. That'll give me the interest per month. So using the answer from above, right, we can plug in those answers. So the formula we're going to use now starts looking the same, but we need to divide by the terms. So if it's monthly, we would divide by 12. If it's daily, divide by 365. And then you're going to raise to the n times t. So here, you would plug in 1 for t, and then 12 for n. So that formula, again, p times 1 plus r over n to the n times t.